let's look at one example to reinforce this idea, and also how are we going to calculate the amount of energy usage. Let's say we are given a certain load profile and we are given a certain kind of chiller's configuration. So let's say we have considered various factors such as price, such as the brands, and you are left with two choices. Okay, and the two choices are buying two. So your configuration 1, okay, is 2 times big chiller, okay, and 2 times small chiller. So you may use this configuration for your chiller plant replacement. Okay, so the 2 times 500 ton is actually your chiller A, okay, and your 2 times 200 ton is your chiller C. Or you can have the second configuration. That means you buy 3 times medium size chillers. Okay, that means you buy 3 times chiller B. So how are you going to choose whether to buy to select this chiller 1 configuration or chiller 2 configuration? So first, what you need to do is to determine what is the best operating schedule, okay, for each configuration. So let's look at configuration 1 first. Okay, configuration 1. If you are looking at configuration 1, during the evening, okay, if you look at the load profile, during evening time, right, during the off-peak period, it is running at 200 tons. Okay, you will require 200 tons of cooling. And during the peak period, it is 700 tons. Okay, it's 700 tons. So the two key tonnage will be 200 tons at night, okay, and 700 tons in the day. So if you are looking at configuration 1, okay, if you are looking at configuration 1, during the night time, obviously you will choose 1 chiller C to be in operation. That means 1 times 200 ton chiller to run at 100%. Or you can also choose 1 big chiller and run at 40%, which doesn't really make sense, because if you run chiller A at 40%, okay, your efficiency is 0.57. But if you run chiller C at 100%, your efficiency is 0.52. So obviously, you will try to choose the one with a better efficiency, that is to run chiller C at 100%. How about the daytime? During the daytime, you need 700 tons, and you only have these two set of chillers. So what you can do is you run 1 times chiller A and 1 times chiller C, 1 at 500 tons, 1 at 200 tons, both at full load. You will get your 700 tons. Okay. Of course, you may also think that you can run 2 chiller A, but at 70%. But if you are using the same argument, again, at 70%, your chiller efficiency is not as good as when it's at 100%. Okay, so in this example, okay, you will run 1 times chiller C at 100% load, and 1 times chiller A and 1 times chiller C at 100% load for peak period. Okay, so this is your operating schedule. So you can set your time schedule. Okay, every day at around 9 p.m. you will start your chiller C. Okay, then at 7 a.m. you will need to start an additional chiller A to cater for the peak load. Okay, so after you get your operating schedule, the next thing is to calculate what is the energy consumption. So what is energy? Energy is actually equal to power multiplied by time. Okay, energy is power times time, and your power should be in terms of kilowatts, your time should be in terms of hour. So your final answer should always be in terms of kilowatt hour. Okay, kilowatt hour. So how do we get the power consumption? Okay, how are we going to get the power consumption? Power, you can actually split into load multiplied by efficiency. If you still remember the topic 2 equation, okay, this triangle, okay, power is equal to load times efficiency. So your load is in terms of R ton, and your efficiency is in terms of kilowatt per ton. So if you multiply these two together, you will get your power in kilowatts, and you multiply by the run hour, you will get your kilowatt hour. So if we look over here at the load profile, let's look at the off-peak period first. Okay, let's calculate this portion, these 11 hours from 9 p.m. all the way to 7 a.m. So let's say it operates for 11 hours. So what is the power at this particular period? You will need to take the load, which is 200. Okay, you will need to take the load, which is 200. So load, so energy is equal to power times time. So you will need to take the load, which is at load times efficiency times time. Load is 200. Okay, your load is 200. How about the efficiency? Efficiency, you will need to get it from the table. So since you are running 1 times chiller C at 100%, so you will need to get the efficiency at 100%, which is 0.52. So 200 times 0.52 times 11 hours. Okay, that is the energy consumption during the off-peak. So you have to include the peak period as well. So you have to plus the peak period, which is 700. Okay, you shouldn't get 700 because you are running 1 chiller A at 500 ton, 1 chiller C at 200 ton. So if we look at chiller A first, it will be 500 ton multiplied by the efficiency of chiller A at 100%, which is 0.47. Okay, you have to get it from this table, 0.47. Multiply by 13 hours, okay, because that's a peak period. And your chiller C, okay, which is 200 ton, multiply by 0.52 multiplied by 13 hours. So these two terms give you, right, okay, these two terms give you the peak. Okay, this one give you the off-peak. So if you sum them up together, you will get your energy consumption for a day. Okay, so I'll repeat. This first term over here, 0.47 times 500 times 13 hours, is your chiller A. Is your chiller A energy consumption during the peak period. Okay, during the peak period. Okay. Then if you add 0.52 times 200 times the 13 hours, okay, this is your chiller C during the peak period. So this whole term that is highlighted over here is your peak period consumption. Okay, your peak period consumption. Then as for your off-peak consumption, you will need to use 0.52 times 200 times 11 hours. Since your off-peak is operating at 11 hours, okay, and also is 200 ton and the efficiency is 0.52. So if you sum them up together, you should get this particular consumption for a day. So make sure you are clear about this step, okay. So we are going to repeat this whole procedure for the second configuration, which is 3 times 350 ton. Okay, we are going to repeat this exercise for configuration 2 before you can make a comparison. Okay, so for configuration 2, during the off-peak period or the night load, okay, you will be operating 1 medium-sized chiller. Okay, since you only have 350 ton chiller, you have no choice but to operate one of them, okay, for the off-peak. So your percentage loading, okay, is equal to your current load, okay, over total capacity. So your current loading during the night time is 200, and the total capacity for chiller B is 350. So if you go and multiply by 100%, okay, you should get around 57%. That means at night you are going to operate 1 chiller B at 57%, and during the daytime it's quite straightforward because you have you need 700 tons of cooling. You can actually safely operate 2 chiller B to get the 700 tons, 2 chiller B at 100% to get 700 tons. So maybe you want to try how to calculate the energy consumption. So energy consumption, let's say we look at the the daytime first. So the daytime you are running 2 times 350 times chiller at 100%. So similarly, you can use 350 multiply by 0.49. These two will give you the power. Okay, load times efficiency give you the power, multiply by the run hour, which is 13. And this is for one chiller B. During the daytime, you have 2 chiller B. So you can actually plus 350 times 0.49 times 13 again. But you don't have to do that. You can actually just multiply by 2, since you know that they are running at the same condition. So you can straight away just multiply by 2. And after that, you have to plus the off-peak period. Off-peak period is at 57% load. So you will take 200 ton multiply by efficiency. Okay, efficiency is a problem now because if you look at the table, there's no 57% here. So what you can do, right, is do a very, just use the estimation, okay? 57% is quite near to 60%. So I think you can just safely use this 60% efficiency. Okay, you don't have to do any interpolation to get the exact number. So you can just use the number that is very near, okay, very near to the percentage loading. So you will just use 0.55 for the efficiency, multiply by 11 hours. So if you go and sum this up, okay, you should get this particular energy consumption, 5669. So if you compare these two energy consumption, chiller 1 actually has a better, is better, okay, because it consumes less in a day, okay, it consumes lesser in a day, okay. So that is one example of how you are going to use calculations to justify the configuration that you are going to select, okay, the type of chiller configuration that you are going to select. Okay, so let's say there's a continuation to this particular example. Let's say chiller 1, although it is better in terms of efficiency and daily consumption, it actually costs more. Let's say it costs 70,000 more than your configuration B or configuration 2. So the building owner actually requires some justification on why you should buy configuration 1 instead of configuration 2. So you have to quickly go and calculate a simple payback period, okay, to justify your answer, okay. So how do you get simple payback? Simple payback, right, it means, okay, it actually means the number of years, okay, the number of years, right, that it will take to get back all your initial investment, okay. So what do I mean? You will take your capital cost, okay, the additional capital cost, divide by your annual savings. Okay, annual savings. So if you look at the units, capital cost is actually dollar, okay, in terms of dollar. Annual saving is dollar per year. Okay, so if you take dollar divided by dollar per year, obviously your simple payback is in terms of number of years. Okay, be it 3 years, 5 years, or 7 years. Okay, so your answer is always in terms of years. So how are you going to get annual saving? Okay, you are going to get your annual saving from your daily savings. Daily monetary savings multiplied by number of days in a year, 365. Okay, you can only do that if your load profile is applicable throughout the year. That means during weekday, weekend, no matter when, right, it always runs at this particular schedule. Okay, so you have to look at the question. It says that it operates 7 days a week with the same load profile. Okay, that is when you can safely multiply by 365. Okay, so how are you going to get your daily energy dollar savings? Okay, so daily dollar savings is actually get from your daily kilowatt hour savings multiplied by tariff rate. So daily kilowatt hour savings, right, is actually in terms of kilowatt hour. Okay, then tariff rate is actually in terms of dollar per kilowatt hour. So if you multiply out, you will get the daily monetary savings. Multiplied by 365 is your annual saving per year, and you will be able to work this backwards. Okay, so the working should look something like this. First, how do you get your daily kilowatt hour savings? Okay, you will have to get the difference. Okay, you will need to know the difference in kilowatt hour consumption between the two configurations. Okay, so you will need to, configuration 1 is 5551, configuration 2 is 5669. That means every day, right, if you run these two chillers at the same time, these two configurations at the same time, how much are you going to save if you choose 1 instead of 2? So you will take the difference. Okay, so you take the difference, and what you do next, okay, you multiply by 365. So this one is your daily energy saving. You multiply by 365, this 43070 is your annual savings in terms of kilowatt hour. You multiply by the tariff rate, okay, you will get your annual monetary savings. So you can see the step by step going up. Okay, so annual saving is 12060. The capital cost is 70,000 more. Okay, so you take 70,000 divided by your annual savings. You are going to get back all your money in 5.8 years. Okay, so for this kind of question that asks for simple payback, please leave your answer in decimal, 1 decimal place, 5.8 years or 3.4 years. Okay, don't have to calculate the number of months and things like that. Okay, just leave it in 5.8 years is good enough. Okay, so the question is 5.8 years considered very long or very short? Okay, that depends. Okay, that depends on the type of equipment you are replacing. For example, if you are talking about maybe a handphone, okay, your mobile phone, 5.8 years to get back your saving is very long, because we know that the lifespan of a mobile phone maybe is around 2 years or 3 years. You will replace your mobile phone. Okay, so if 5.8 years is the payback, then it's not worth it. But for a chiller, we know that a chiller typical lifespan is around 20 years. So if your payback period is 5.8 years, it's considered a good investment, because the rest of the years, right, you're actually enjoying your true savings. Okay, the rest of the years. Okay, so 5.8 years is considered a good investment, and chiller 1 configuration should be selected, and is good enough to justify why you should select chiller 1.